Today, our topic is about the Zener diode. It's working as a voltage regulator for high voltage and as a breaker at low voltage. Firstly, I start from discussing about. Firstly, I will take start from the introduction. Actually, Zener diode is a heavy doped diode, uh, which is designed to work on reverse wise, and uh, it is doped in such a way that it will not damage when voltage cross the Zener diode limit. Okay, so. Actually, it is activate at Zener at reverse wise at Zener voltage. The, so actually, the symbol to represent this diode is simple diode is representing by this symbol. Okay, this is a simple diode where this is a P region and this will be N region. But Zener diode is like this. This is only difference in symbol. This is the symbol of the Zener diode. Okay, and it work on both reverse wise and it is it also work its working is a good at reverse wise as well as the in forward wise as a simple diode, but it is specially designed that it also work very good way in a reverse wise even high voltage region mean the even at the uh, breakage voltage region, or you may say that at the Zener diode region, as I have already discussed in my previous lecture, what is the meaning of Zener voltage? Okay, so this is the symbol of the diode. Now I will explain how it. I will explain its working. Actually, we now I have already explained that in my previous lecture that. This in the semiconductor device they have a zero. uh, if I draw the current voltage diagram, if this represent the current and this x-axis represent the voltage and y-axis represent the volt current, then the when diode is forward wise, then at this region, this is the current will be remain the zero near to zero because due to the stopping potential, then it will uh, start current will be start to flow in the start to flow in a non-ohmic region. But after then this will become ohmic region. I have already explained in the all these in previous lecture. So this is uh, this is a sorry, this is a uh, zero zero current. This region is uh, parabolic when the current behavior is like a parabolic. So it will be because it a parabolic. It is not a linear uh, voltage and current relationship is not linear. So that will be defined as a non-ohmic because. Uh, the behavior of current and voltage is not like a ohmic region. So this will be defined as a non-ohmic region. I have already uh, uh, explained in detail in my previous lecture, and this region will be defined as a uh, ohmic region. Ohmic region. Okay, but in reverse wise, we know that the leakage there will be a, okay, sorry, this is due to stopping potential, and we know that this is due to potential stopping potential or retarding potential. Actually, this is a retarding this it uh, uh, actually semiconductor actually diode uh, have internal retarding potential uh, in the depression region. So when and I have explained why in the previous lecture I have explained why that will be why there will be a created depression region, and why there will be uh, a stopping potential or a retarding potential. So at this region, the potential there will be a stopping potential. Okay, when no external field is applied. Okay, potential. So similarly in the reverse case, firstly current will be zero, and then it will be a very small current will be flow in the reverse region. Okay, sorry. So and there will be a constant current, but after passage of some time, there will be a the Zener voltage region. Okay, here the current this current will be a saturated current. Okay, so this current will be defined as a saturated current. Okay, because at at y-axis this will be a current, but these voltage uh, Z naught and ZF, this will be the Zener voltage. Okay, this is defined as a these at y-axis we have now that these are the as we know that along the y-axis there is a voltage, so this will be defined as Zener voltage. Okay, so Zener diode will be activated on this region. Okay, I should. So this is the Zener diode region. Okay, so Zener diode will be activated on this region. Okay, how its function, what is this working, and how its function, and how it uh, now I will explain how it work as a regulator. Okay, uh, so working as a voltage regulator for high voltage. So now I will define it how it will be work as a voltage regulator at high voltage region. Working as voltage regulator for high voltage. For this purpose, uh, we connect the Zener diode in parallel to load. We know that what is the difference between load resistance and simple resistance. Load resistance is like the resistance of our appliance, and where uh, uh, we are interested to regulate the voltage. That voltage must not exceeded, which may damage the our appliances. Okay, so for this purpose, this circuit diagram for voltage regulation, to regulate the voltage, we use the Zener diode in series. So you may say that if I apply the resistance here. Acha, okay. Okay. Firstly, it is used for as a high voltage regulator. Both it is firstly you should must know that it is used as a voltage regulator both for for DC and AC voltage or current. Okay, current. So it is used as a voltage regulator both for DC and AC voltage. But firstly, I will explain its function for the DC. Firstly, we I will explain. Uh, firstly, I will explain it as a voltage regulator for DC voltage. So voltage. So now I will discuss it. Firstly, I will discuss it as a voltage regulator for for DC current or voltage. So firstly, I will discuss it for DC. Okay. Okay. So how it work for the DC? If you have for a voltage regulator regulate for high voltage, I have to regulate high DC voltage. So for this purpose, uh, we use the diode. We use Zener diode in uh, in parallel to load resistance or load. Okay. So what we will do, we will uh, apply Zener diode. Here we have plus minus because we will here will be the load resistance, or you may say that here is a load. So this is as we know that this is N and this is P. So this is you may say that this is a variable resistance. Okay. So uh, it must be a very small negative represent by the small terminal. Okay. So this will be this is sorry here I so, here will be some resistance or so that to control the voltage must not exceeded the current must not exceeded the limit of the diode. Okay, so what will be happen, the current will when the current will pass through the resistance, and then it will be divided into the two part. One will be current will be passed through the Zener diode, and the other part will be it will pass through the so you may say that the this current, sorry, uh, you may say that this current will be divided into the uh, IL and IZ. So total current will be IL and plus IZ. Okay. Okay. When what will be happen when how it regulate the voltage for high uh, so if for voltage V less than Vz, if the voltage is less than the Vz, then as we know that this Zener diode is will be act as a reverse vice, and uh, if this is V is less than Vz, okay, when V is less than Vz, then there will be only the leakage current, and no current will be mean you may assume that there is no current will be flow from the Zener diode. Okay, so then this diode will be act like a open circuit. Okay, for voltage V less than so this so for this the RL. Okay, so so this so Zener diode, sorry, so Zener diode will act like a open circuit. You mean as no current will be flow from the Zener diode. When all current will be passed through the you may say understand that all current will pass through the IR. So I will be become a IR. So all current will be. What is the voltage? V or you may say that V output. I mean output voltage will be equal to V input. Okay, if I say that this is V input. So output voltage will be equal to input. Whatever, what is the output voltage? जब तक up till when the input voltage is less than the VZ, all the voltage will be drop across the load resistance. So, so all voltage will be drop across only the load. So the input voltage will remain the same for output voltage will be the same as input voltage. Okay, but if in the case okay, but if in the case of uh, for for voltage V in is greater than VZ, then this obey so that will be that is the Zener region. Okay, uh, I should change the color. I mean, this is the Zener voltage region. Okay, for this region, when a voltage is greater than VZ, okay, sorry, VZ naught, okay, so greater than VZ or VZ naught, okay, or VZ. So for voltage input is greater than VZ, then for this region diode will be obey you may observe from here, you may observe from here, sorry, okay, from you may observe from here that the voltage is constant. Okay, there is little bit distortion mean voltage. The bandwidth of the voltage is a very small, means Z naught and ZF is a very small. So voltage in this region, the current will be current saturated current will be pass through the diode. Okay, and okay, so the current will pass through the saturated current will be passed through the diode. Okay, so in for this region, the voltage remain the constant. So this is the region where the voltage will remain the constant. Okay, so for this region, what will be happen? Your what will be the equivalent circuit for this or working of equivalent circuit mean the working. Okay, uh, so this region and this for when voltage will be high. Okay, so all the voltage will be I must explain what will be happen. Okay, so for this when voltage is greater than, then this diode the current will be stop crossing from here. Okay, and uh, the current will be will behave like you may say that, and the voltage will be constant for this, and this will be like You may said that this is also like a battery, okay, that will behave like a, and V will be equal to VZ, okay. Mean jitni mean when the if you voltage will be increased, the voltage will start to dropping across the diode, and the current will pass through so this will be RL. So the voltage will remain the same at so you may say that because both are connected parallelly, so I think I must draw or okay. So so the voltage drop across this, that will be equal to VZ. The but remaining all voltage will be drop across this because this will behave like a uh, battery. Okay. Actually, what happen? Actually, when voltage increase, the current start to uh, pass through the diode. Okay, Zener diode. Okay, because it will goes to the because it moved toward the saturated region. Current will be increased. I mean, the diode will behave like a all excess current will be passed through the diode. Mean and voltage will be dropped to the again back to the in the region of the Zener diode. So voltage can't be increased from the Zener diode. So the it regulate the voltage across the sorry, across the load. Mean if this is a Zener diode, for example, if I say that, for example, for example, if Vz equal to let's suppose 5 volt, mean this is the Zener voltage 5 to there is some uh, 5.5 volt, then then when so uh, for Vz equal to 5 to 5 minus 5.5, the when V V in mean input voltage is less than Vz, mean 5 volt, then uh, V out or at load, that will be equal to V in. But as it exceeded the Vz, for example 5 volt, then it will remain V out will be remain the uh, Vz, mean that will be 5 volt. So current will never increase. So current will never cross the limit of the Zener diode voltage. Okay. So this is the purpose for the Zener diode when we connected it in the parallelly to road resistance. Okay. So this will be okay. For now, the other second case, how we use the as breakage at low voltage. So now we will discuss the Zener diode as breaker of breaker for low voltage. For low voltage, For low voltage, we have to connect Zener diode in the series. For example, if I use the Zener diode in series, but it must be a reverse bias, okay, across the load, then what will be happen? As we know that this is N region and this is P. So, so it will control the uh, how it control uh, for for the case V in is less than Vz. For example, this is in a diode of Vz. Then it will behave like when V in is less than Vz, then uh, there will be only leakage current. So, so diode will behave like uh, open open circuit. Okay, so when it will behave like a open circuit, what will be equivalent circuit? As we know that when it will behave like a open circuit, so no current will be so it will stop the flow of current from load, and it will save our device mm, 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 our device to be damaged. Okay, so when so it will be stop the flow of current from the load, and it will save our device to be damaged or not work at low voltage. Okay, okay. So, but when V input is greater than Vz, mean that is in that Zener diode that is connected in series, then then uh, saturated current flow will be started sorry started across Zener diode, and it will behave like open circuit. So what will be the equivalent circuit for this case? Your equivalent circuit will be like this. Uh, it represent the voltage may be a vary. Okay, so that's why I use this. Mean V voltage will drop across this. So V out or V load will be equal to V in. But here V out will be equal to 0. For this purpose, for this circuit, when voltage is less than, then that will be a 0. And we may summarize it in this that so when Zener diode will be in series, then and Zener voltage is V equal to mm, let's suppose firstly I have choose that is five. For example, Zener voltage is uh, 3 to 3.5 volt. Then what will be happen? Okay, if the voltage is from 3 to 3.5 volt, then what will be happen? Uh, then when V is greater than Vz, this is Vz, okay. 3, 3, then V out will be equal to V in, input voltage. Sorry, must use this. V in will be equal to V out. But when V in is in the case of Vz less than sorry, Vz that is less than 3.3, okay, then V out will be equal to sorry, V out will be equal to 0. So no current will be flow from the when voltage will be low, then no current will be flow because that will be like behave like a open circuit. But when V in is greater than, then that will behave like a short circuit, and then all current will be passed through the load resistance, and voltage will remain the same across. V out will be uh, equal to V in. Okay, but if we are interested to uh, regulate voltage. We are interested to keep voltage maintain between uh, 3 to uh, 3 to 3 point, sorry, 5.5. Then what we have to do? Okay, to keep the maintain the voltage between uh, maintain between 3 to 3.5. I think I must write keep voltage maintain between 3 to 5.5 volt. If I am interested to maintain this voltage between these two, then you may maintain, how we may discuss in exam, we may say that maybe I want, because Zener diode may work on between from 2 to, uh, in industry, there is a 200 voltage. So you may maintain the voltage between uh, 110 to 202, but it depend upon the given problem. Okay, but AC voltage, I will how it function will function for AC wave, I will discuss it later. But now I will discussing for DC case only. In the next lecture video, I will share how it will maintain the uh, regulate the voltage, high voltage, and and work as a breaker for the low voltage for AC wave in the next. So so now we discuss it for this purpose. We have to use, as I have already explained, that for this as for maintain for controlling the high voltage, we must use the Zener diode in uh, Zener diode in parallel, as I discussed in the uh, this case. The Zener diode must be connected parallel to load or your appliance, and for as a using as a breaker, you must use the diode in series, Zener diode in series. So to work in 3 to 5 VZ5 volt, we have to uh, sorry, uh, sorry, I think I'm not, is there any problem? Okay, uh, for this purpose, this is resistance. Okay, to maintain high voltage, I must I think I must. uh, L. Uh, this Zener diode, this Zener diode. Oh, sorry, I think I should use the this color. This VZ of this Zener diode VZ must be if I say that this is a uh, Z2, okay. For example, like if I say this is a Z2, then it must be around about 5 to 5.5 volt, and this Z1 will be uh, from 3 to 3.5 volt. Okay, so there will be three cases. Okay, so case firstly I discuss the case one. This is circuit to maintain the voltage between 3 to 3.5 voltage. It will be when voltage exceed to 5.5 volt, it will regulate the voltage and uh, give the voltage equal to 5.5 at your appliance or your load. But if the voltage is low than 3 volt, then it will break the circuit and no current will be flow through the load. Okay, so it will save our device for both cases. How it will work, I know I will discuss. For example, case is one. If if uh, V in is less than 3.5, is less than 3 and also less than 5.5. Okay, Zaid, 3, as we know that 3 is less than 5. If the input voltage is less than 3, then it is understood that will be less than 5.5. So in this case, for case 1, the no current must pass through the load. Sorry, this is not load, this is a resistance to maintain the current must not exist the to maintain the current in the safe region of the diode. Okay, so for this case, when V is less than 3, then as we know that because voltage will be less than, so as I have discussed in, for less than V is less than V in that the diode in series will behave like open, or diode in is will be also behave like a, because when the voltage is less, then both will be like behave like a open circuit. Okay, so when V in is less than 3, mean input is less than Zener voltage, that is you must remember that this is VZ1 or this is VZ2. Okay, so sorry, I must write this is VZ1, this is VZ. So because the when voltage is less, then diode will behave like a open. So both load both diode will be behave like open, because no current will be flow from this. In this case, V out, yeah, V load is 0. No current, no voltage will be dropped or no current will be flow from across the resistance. Okay, but case 2, case 2, if V in is uh, if V in is Vz, if V in is greater than 3 Vz1 and less than, sorry, input greater than V input, but uh, greater than input and 5 volt. I mean, if voltage uh, between the limit value, mean not less than 3, not greater, mean less than uh, the voltage is greater than 3 volt, not less than 3 volt, and not greater than 5 volt. Mean if input voltage is in the between the safe region, then output must be equal to the input. Okay, so let's see what happen. What will be the equivalent circuit in that case? In that case, V in is greater than 3 volt. Okay, so uh, greater mean the diode D1 will behave, sorry, D2 will uh, diode Z1 mean 3 volt diode will behave like a forward wise because voltage is greater than VZ1, and VZ2 voltage is less than VZ2, so that will be become a behave like a open circuit. So equivalent circuit diagram will be like this. Here from it will be open. So all right, this was a VZ2 because this was a VZ2, this was a VZ1. So uh, because V in is greater than V is greater than okay, because V is greater than VZ1, that is it was about 3, and this was a VZ1. Okay, sorry, this is a, sorry, this is was a 5 volt, this was a 3 volt. So the VZ1 will behave like a forward wise. Okay. Oh, sorry, not will behave like a short circuit. All current will be passed through it. And VZ2, which is up in parallel, that will behave like an open circuit. So all current will be passed through uh, the this resistance, load resistance. So no current will be flow through the VZ2 or diode 2. Okay. So you may say that V out will be equal to V in this region. This region. Okay. Now we will discuss the case 3. For case 3, when V in is greater than 5, mean it is greater than 5 volt. So if it is greater than 5 volt, 5 is greater than 3 volt, I know that. So definitely it will be also greater than. This is 5 volt is VZ, Z2, and 3 volt is VZ1. Okay. In this case, what will be happen? So both are both will be a forward wise. Okay, so both circuit will be behave like us. So as I have already discussed, in that case, both diode will be behave like a forward wise, but in series because current will be divided. So this will be like this. The VZ, this will be 5 volt. Okay, so but row. So at V out, so V out will be equal to 5 volt. VZ. So in this way, in case 3, current will be not increase, even not equal to V in. Mean voltage will maintained is for, even if the voltage input voltage is greater than 5 volt, but our appliance will receive the voltage equal to 5 volt, even input voltage is good. So it they that so this circuit will save our circuit, our appliance from to be damaged. Okay, so this is uh, all about using the Zener diode as a uh, voltage regulator for high voltage and voltage breaker for low voltage. So this is all the about this. Okay, so when we apply it, okay, 1 minute. Okay, so when we apply it in a series, sorry, in parallel, then it regulate the voltage, uh, and the voltage, it will stop the voltage, high voltage pass through the load resistance, uh, and it regulate the voltage equal to the Zener voltage. Okay, provided Zener voltage, which is connected in parallel. But when voltage exceed to the when the voltage, input voltage or incoming voltage is uh, uh, less than the required voltage, even then the circuit, the Zener diode in series will behave like a breaker, and the no current will pass through the load resistance. Okay, but keep in mind this explanation is for uh, the working of Zener diode for as a voltage regulator and as a breaker for low voltage for DC voltage. For AC voltage, you have to watch my next lecture. Uh, thank you for keep watching. If you have any question, any confusions, or any feedback, please don't feel hesitation and uh, uh, please put your question, your feedback and suggestions and your questions on comment box. Thank you very much. Goodbye.